Well, thank you for the introduction, Dan. It's a pleasure to be here. Just kind of help reiterate and emphasize the importance of the safety, because we want to, at the end of the day, protect you, your pigs, everybody around you safe, and make sure we're following the best practices possible. So I'm going to go through kind of brief little detail on some of the information we have on pit pumping and agitation safety. Why do we need to do it? What's important? What to look for? And how to keep you safe. So why do we need to ventilate during pumping? I'm sure, as all of us know, as the manure gets agitated, gases are released, and those can trickle up into the airspace. Those gases can be deadly at certain concentrations. They can cause mortality, as I think Dan had on some previous slides. Some of the pig mortality pig numbers from the last couple of years been slightly on the rise. So all the more important to keep this information fresh in your head. Reflect on it now when you're probably not out pumping your pit right now, but just kind of think about it, keep it in the back of your head, so when it does come time to do it, you have all this information there. So what gases do we need to be concerned about? There's kind of four primary gases. That's hydrogen sulfide, H2S, ammonia, NH3, methane, CH4, and carbon dioxide. I'm sure we've heard these. We're kind of familiar with them. But the one that's really important to keep in the back of your mind is hydrogen sulfide. One of the key characteristics of it is it smells like rotten eggs. I'm sure we've all smelled it before. But the problem is it can desensitize your nose at a low concentration, which makes it harder to detect the higher concentrations while you're around it. One of the other attributes of it is it's heavier than air. It's going to pool up on the manure pit surface right below the slats, so that's why we'll get into later on agitation practices, why it's important to make sure you have that 1.5 to 2 foot gap below the slats. It's the most dangerous. It's the one we got to watch out for, and the one we eventually will have to monitor. Moving on, ammonia. This one has been kind of picking up recently. It's been kind of, we always know it's there, but the concentrations have been increasing in the last couple of years. I think that was what Dan Anderson told me earlier. It's also heavier than air. It can quickly cause burning, watery eyes. If you can tell sometimes in your minimum ventilation, that kind of stinging is usually caused by a little bit of ammonia, concentration getting a little high. So it's another one to keep in mind. So methane, while only important at kind of the higher concentrations, as it's lighter than air, it's going to float up. It only really matters in that greater than 50,000 parts per million, and at that point is where it can cause explosions, fire, or asphyxiation. And while that's bad in your barn, it is good in an aerobic digester and why it's used for energy creation. Last one, kind of carbon dioxide, we're probably all familiar with. Heavier than air, a little bit difficult to detect as a human. Sensors are good at it. Just something to kind of keep in mind when you're pumping your pits. Moving on into monitoring, as again, I'm going to pick hydrogen sulfide out here. There's a really great fact sheet that goes through a bunch of different sensors that's available on the Iowa Extension store. But kind of roughly to go through at 0.01 parts per million, which is very, very low, and that's when you can start to detect. But as we start to move into like the 2 to 5 parts per million, and at prolonged exposure, it may cause nausea, tearing, headaches, go up 4 times, and now we're at fatigue, loss of appetite, headache, dizziness, moving into 5 times into 100 parts per million, coughing, eye irritation, loss of smell, and potentially death after 48 hours. And even at the higher concentrations, 500 to 700, we're at staggering collapse, damage to the eyes, and death after 30 to 60 minutes of exposure. And at the higher concentrations, it's very quick, rapid unconsciousness, collapse within 1 to 2 breaths, death in minutes, and even at the max, it's almost nearly instant death. So one of the key things to think about here is when choosing a monitor, we really have 2 types of monitors. There's a real-time monitor and a kind of just a monitor that's just going to have an audio or visual alarm. And so that's all it's going to do. It's going to have some threshold in it that's going to alert the person wearing it where they need to react, versus on these real-time monitors, they're going to have a parts per million readout where you can see what the numbers are and then go on to make a management decision where you can change your agitation practice or do something different if you actually know what the concentration is. But they are slightly more expensive. So, where are the dangerous locations? I'm sure we all have been around. I think this video, courtesy of Dan here, if it plays, forgot to embed it. Okay, so I think if you have seen it, you see that the smoke coming out of the smoke generator there is going down into a pit, and that pit is essentially acting like an inlet, shown in that upper right-hand picture. That smoke's being drawn in assuming you're having your exhaust fans on. Fresh air smoke is being brought in, picking up that gas off the headspace and putting it right into the breathing zone of the animals. So that's what we'll get into a little bit later on pump-out curtains, but that's essentially, make sure those unused pit covers are sealed, or where the agitator's at is make sure a pump-out cover. Another kind of particular spot that you might not think about is just kind of downstream of the exhaust fans. Whether you're in your tractor or walking around the outside of the building, just be mindful of all that gas is coming out through those fans, and if you linger or start to feel dizzy afterwards, it's probably because you've taken in a little bit too much from standing downstream of the fans. So we kind of know the who, or in this case the gases, the what, the when, where these locations are, and why is it important and what it can do. So what can you do to keep yourself, people around you, and the pig safe? So I'll briefly go with the agitation strategy. Not quite my expertise. I'm more on the air moving side of things, but again, I kind of borrowed this from the fact sheets from Dr. Anderson. Again, this is don't agitate until the manure level is 1.5 to 2 feet below the slats. As I said, hydrogen sulfide is more dense. It's going to pool up down there, so it's important to make sure we get the level down with the hydrogen sulfide so it's not being stirred up and kicked back up through the slats and into the breathing zone of the animals. So we keep that separation. Another practice is avoid aggressive agitation when animals are in the building, no rooster tailing, and surface agitation can also cause more turbulence, breaking up those solids, releasing hydrogen sulfide, and causing it to go up into the animal space. Also, do not direct the agitator nozzles towards pillar walls or towards a corner. Hydrogen sulfide kind of likes to pool up in those stagnant areas. So if you're shooting in there, it's going right up. There's probably not a whole lot of air moving there. So that's kind of what we'd like to make sure we're not aiming right there. Keep the agitator below the surface at all times. So that means probably stopping when the bottom nozzle is less than 6 inches below the manure surface. Also try to avoid any sudden changes in agitator depth or intensity that's going to break stuff up, cause a rapid release of hydrogen sulfide, which could eventually cause problems. So some other just kind of key operation procedures. Never enter the building while pumping. Probably said it, never enter the building again without pumping. That's probably the most important one that you see repeatedly over and over and over again. There's ways to prevent this. Use caution tape on the doors, put up markings that indicate that agitation is going, let people around you know, alert somebody. There should be somebody there anyways. And that person should have a copy of an emergency action plan. They should know what to do in case of the event of emergency or if anything was to go wrong. Have a H2S monitor handy. Just because you bought one, you actually got to use it to make it effective. It doesn't do any good sitting at home. It's got to be on you when you're out there. Prohibit smoking, open flames, or sparks that could potentially cause any combustion inside the building. Try to avoid that, and always kind of keep an eye on the animals. At the end of the day, they're a good source of feedback for figuring out if there's any pit gas being involved and they're showing any signs of stress. So kind of some other things to think about is making sure heaters are turned from auto to off. Possibly turning the LP off at the tank. If the inlets are on a manual setting, make sure they're 100% open. Turn those feed lines off as a possible source of the spark. Turn the lights off at the breaker. Really try to minimize the possibility of any kind of combustion happening. Moving on from some procedures on into ventilation. So I'm going to go through kind of two different ventilation strategies, whether you have a mechanical ventilation or a curtain-sided barn, and then we'll go through kind of different warm weather and cold weather scenarios. So starting with curtain-sided barns that do have some mechanical ventilation, the pit fans or another minimum ventilation fan. Typically, we want wind greater than 5 miles an hour when that wind is perpendicular to the side of the building. When that wind's coming in at an angle, it's going to need a little bit higher, from about 7.5 to 10 miles an hour, to make sure we're clearing, getting enough air exchanges through the room to reduce the concentrations. Let's make sure those sidewall curtains are open and all those exhaust fans are moving air. In the event wind is less than 5 miles an hour, mechanical ventilation is going to be necessary. This is where you're going to close the sidewall curtains and using all the exhaust fans to create the suction to pull fresh air in and exhaust it through the room. The last kind of little note there is if more than 50% of pit fans are removed for pumping and agitations, those curtains should remain open regardless of the wind speed. Kind of a little side note to think about, because again, we don't want to be pulling fresh air in right through the pigs. So that works well in warm weather. Kind of different strategies needed in colder weather, and this is probably where a lot of the problems come in, and especially with the smaller pigs, because we don't want to cold stress them and chill them. With the bigger pigs, maximum ventilation works. Smaller pigs will have to be a mix of mechanical ventilation and using at least a minimum of 25 to 30 cubic feet per minute of air per pig during the pump out. And that's again just to make sure we're getting the air exchanges needed and hopefully not causing any cold stress damage to the pigs. This also can create some static pressure problems in the room, so make sure ceiling inlets are open fully and the curtain might need to be dropped a little bit to reduce that pressure. And with stir fans, if you have any in the building, make sure those are directed to the parallel flow. So if it's across, make sure it's moving air with the wind and you're using everything's going together. So moving on into a tunnel-ventilated barn. Starting with the warm weather case, let's make sure all pit fans are running and at least two large, at least a 36-inch diameter fan. Tunnel fan is also running as well. Open that tunnel curtain on the end wall about 6 to 12 inches. And ideally, you get around 300 to 400 feet per minute at that inlet, which is making sure you get enough airspeed and momentum to get the air exchanges in the room to exhaust the gases. Make sure the ceiling inlets are partially closed if they're powered to force air through that curtain. And another key part here is even once you're done pumping, don't shut everything off. Keep ventilating, for at least 2 hours, and I think I've seen recommendations from 4 to 6 as well, to keep making sure air is moving through the room and any lingering gases are all exhausted. Pump out curtain, I'll get into here on the next slide. Cold weather strategies for tunnel ventilated barns. Run all the pit fans and maybe at least one 36-inch fan. Again, keep that tunnel curtain open, similar to the warm weather scenario. Keep ventilation moving air for at least 2 hours post-pumping. And pump out curtain again, and kind of similar situation with the stir fans, keep it parallel to the flow. So in a tunnel situation, make sure those are pointing down towards the exhaust fan so it's pulling air with the exhaust fans from curtain to fan. Just some kind of other strategies is using that pump out curtain. As you see there in the upper right hand corner of what the pump out curtain is supposed to do, it's supposed to kind of create a seal between the headspace, or between the manure level and the headspace, so that we're not pulling that air directly into the animals and kind of keeping, since hydrogen sulfide is heavier, it's going to stay down, and we're not pulling fresh air through. So that's what kind of our pump out curtain is supposed to do. And as you see in that bottom right hand corner, it's not quite all the way down to the manure level, so it's kind of a little bit ineffective there. So make sure it's actually, when it's installed, it's doing what it's supposed to do. There's kind of a tarp example there on the left as well. Watch for changing weather conditions. That could be wind for current side buildings, and same with temperature changes in the day. With that night air being wind's going to tend to die down at night, as I'm sure we all know here in Iowa. So it's something to keep in mind, that be aware that with those changing weather conditions, that's going to change where gas goes and how much it's being exhausted through the barn. You can also use, if it's calm, use a PTO-driven fan to increase ventilation is one option. You can also turn on stir fans and move air and try to minimize those dead zones in corners of the room or wherever else might be a problem. So that kind of wraps up what I had on ventilation strategies during pit pumping, and now kind of getting into something I'm a little bit more related to and spend a little bit more time doing, and I think everybody always needs a good refresher on some best practices in cold weather ventilation. Kind of the next couple slides are from some National Hog Farmer articles I wrote last winter, I believe, so just kind of to recap, because I like these slides and kind of the information. I think they're always kind of good to hear again, to talk about minimum ventilation during the cold weather, kind of like now, even though we're getting a little warm. So one of the kind of key aspects of minimum ventilation that I think some people get tripped up on is when we design for minimum ventilation versus when we operate at the minimum ventilation stage. During that design portion of the minimum ventilation rate, we're taking into account the number of animals, the number of air exchanges needed, really to control the amount of moisture inside the room. And so there's some set number of CFM per head that's needed to achieve that minimum ventilation rate. And we use that as engineers to figure out the diameter of the fans and the number of fans needed to hit that design minimum ventilation rate target. We sometimes are not always right. There is genetics, the way the barn's constructed, infiltration, leakage through the barn, all affect this minimum ventilation rate. And that eventually could be adjusted. Sometimes it is right the first time, but not all the time. So that's where it comes into really observing the pig as the feedback and adjusting that minimum ventilation rate. Well, it's not easy if you need to add more fan capacity. You can't just go add another pit fan. But things like adjusting inlet opening, current opening depending on the building, variable speed rate, kind of use the pigs as the feedback to adjust the things that affect that minimum ventilation rate to figure out what the animals need or what's best for them. So it's kind of wanting to differentiate the difference of, do we actually need to measure the flow rate to make sure we're hitting our design target? No, not really. We just really need to make sure the environment in the barn is best for the pigs. And that's what kind of the goal is. Static pressure. Use exhaust fans to create a slight vacuum. And this vacuum is what drives the air through the inlets or the curtain. The indoor pressure is going to be lower than the outdoor, which creates that suction. So you kind of see in the picture there, we have the slight vacuum going in through kind of older sidewall inlet there, just to show the example of how we pull the air out through the barn to create the suction, and we create this static pressure difference across the room envelope, which is the walls, to move air in the building. So ideally, we want the static pressure right around 0.05 inches of water column during kind of the lower ventilation stages, and upwards of about less than 0.12 in the higher ventilation stages. And we can do that with a manometer, kind of the one shown there. That's probably the most common method to measure static pressure. Just make sure to zero it first. There's levels there to make sure it's not off to the side, which can really mess up your measurement. Free of dirt in the tubes, as that can affect it, and making sure the tubes are buffered from the wind, as wind can significantly impact the pressure reading. Kind of my other third kind of key take-home is airflow from ceiling inlets. It's assuming that we have enough sufficient static pressure across our room envelope is what we need to create a good jet coming out of that inlet to create a nice rotary mixing pattern, as we see there on the left. That cold air comes in a jet. It removes moisture and gases off the pigs and kind of makes a recirculation and finds its way out through whatever fan we're using. In the event that there is not enough static pressure, as shown on the right, we tend to get a cold air drop, which I'm sure everybody has noticed. As you stand directly under the inlet, you feel that cold air rushing right down on your head. Because there is not enough momentum to get that air across the room and achieve the rotary pattern shown on the left. Instead, you get a cold air, small little recirculation, and a bigger recirculation zone that kind of turns into a dead spot that accumulates gases and humidity. Kind of one of the problems we see with the leaky barns, and that's kind of what motivated this slide, was with leaky barns through unused tunnel fan shutters, curtains, doors, all other spots where air can leak in. It creates situations where there's not enough static pressure, and we see more often than not the picture on the right instead of the ideal picture on the left. So there's methods of closing up some inlets or adding fan capacity to help do that, although you don't want to pay extra LP to achieve that. So having a nice tight barn really is a critical step in moving forward for improving air distribution and the quality inside our rooms. So kind of with that, I'd just like to say thank you and thank Dan again. I'm not sure if you scheduled time for questions, but if not, my contact information up there, email and phone, and I want to thank Dr. Anderson for all his help and the Iowa State University Extension and Outreach fact sheets. Thank you.